We are now pleased to welcome on stage Chris Mills, NVH Manager at Hyundai Motor Europe Technical Center. Chris will show how the NVH Simulator has been used as an efficient tool in product development at Hyundai in the past years, and how it will be integrated into virtual NVH development in the future, enabling an analog interface to the digital world.
So, thank you and good afternoon. Yeah, like we said, I want to talk about an application where we're using the NVH Simulator in real development programs, and we'll also touch a bit on future integration of virtual development. So yeah, I'll introduce the NVH Simulator, and then we'll talk a bit about the application in the product development, talking about the active sound integration and the development process that we use. And then we'll tap into the future integration into virtual development. So, yeah, the NVH Simulator. The NVH Simulator is a tool that allows us to drive virtually a vehicle when we don't specifically have a prototype available, and that we can evaluate the real interior sound of that vehicle, also at very high accuracy. So maybe a little bit different to some of the other applications of the simulator of how it works. Sorry, the first stage when we go to a simulator model from NVH is that we have to record some data. So we take a vehicle, we go to a proving ground, and we have to do many different measurements on different road surfaces and different driving conditions, measuring then acoustic responses, and also measuring the vehicle performance. Then we can move on to once we have the data set, we move on to the post-processing. And here we have to then decompose all of that data into the different sources and resynthesize the data. And this then leads us to build or assemble the model back into the simulator and validate the model. And we do this by validating the resynthesized data directly with the original data that we measured on the track, and then we can make sure that the model is robust. And then, obviously, we can start then our other work of, for example, sound design and also customer evaluations on the simulator. So at Hyundai in HMTC in Rüsselsheim, we have a standalone NVH simulator, and we have also a static driving simulator. The standalone simulator is probably what we use the most at the moment, and the main reason for this is the ease of use of the system. So there's, of course, some benefits of using a fairly or a dedicated standalone simulator. We can easily and quickly develop the vehicle performance model. It's easy to integrate or make changes, so the person can be actually driving the simulator and having the laptop at the side of him and quickly then do adjustments and directly drive again. Whereas if you're in a full cockpit, it's quite difficult to have a laptop next to you or something. And maybe less immersion is not such a positive point, but the benefit of less immersion is there's less time required for drivers to get used to the simulator. And I think some of you know the issues of putting somebody new into a simulator when too much immersion is there, that they very quickly get sick. So if we move then onto the static simulator, of course, then the move is to integrate into the NVH simulator into the static simulator. And of course, then this gives the big benefit of immersion, of driver immersion. Of course, the environment's much more realistic, so the driver perhaps drives a bit more realistically as well. And also, we get the possibility to have simultaneous evaluation of multiple attributes. It's not just NVH. Okay, I'll just talk a bit now about the integration of active sound system. So sorry, I'm still getting used to the delay on this. Yeah. So maybe first I'll just explain a little bit what active sound is. So active sound is the addition of a simulated sound or an additional sound that we can play into the vehicle interior to enhance the feeling in the vehicle. So maybe with ICE vehicles, it's just enhancing the engine sounds, and with electric vehicles, it's maybe bringing emotion into the vehicle. The example I give here is an ICE. So, of course, what we first need is the actual vehicle itself, and we need the input from the vehicle. So we need to know things like the vehicle speed, engine speed, some of the throttle positions, etc. Then we have also an ECU, or a sound module inside the vehicle, and this basically takes all of the information gathered from the vehicle, like the vehicle speed again, or RPM, and then calculates the desired sound that we want. And then finally, we have then the replay system inside the car. This can be either loudspeakers, or can also be, for example, an actuator that's connected to the vehicle structure somewhere and then radiates the sound inside the vehicle. So in the end, what we get is a vehicle that has enhanced emotion or enhanced sound. And in this example here, we have then, in the end, 3 different driving sounds, and now you'll be able to hear some of them driving sounds. So first of all, we have the normal. And then we can move on to the sports mode. And then the N mode in this case. So yeah, as you hear there is distinct different sounds, and as we're going up into the more sporty modes of the vehicle, we can then enhance the driver experience. So, yeah, we need to then apply this into the NVH simulator, and why we do this. During the development of the active sound, there's an extensive sound tuning required to get the right sound. And also, as sound is quite subjective, it's also very important that we do jury evaluation and get the feedback from internals, customers, managers, so that we develop the right sounds for the car. And some of the benefits of using the NVH simulator, we also have a hill system I'll explain a bit later, is that we can quickly create sound concepts created using the production active sound design software. So this is an important point for us. We're not using a third-party software or something. We're actually using the software that we integrate then into the vehicle at the end of the day. We have a significant cost and time saving compared to driving a vehicle, so we don't have to pay proving ground costs of taking the vehicle, and also time. Of course, it's much quicker to drive on a simulator than in a real driving condition. We don't have to worry about traffic and other things. There's also less requirement on development vehicles, so we just need the vehicle quite close to the beginning for creating the original simulator model, but then we have no requirements on the prototype vehicles. We can do everything on the NVH simulator. Then we come to the customer evaluation. So this is also much more efficient on the simulator. So again, we save weight and cost and time. So it's much quicker to drive for a customer to get into the simulator and drive. And of course, there's also less cost involved. We can also remove the brand imaging, which is also sometimes quite important. We don't always want to, but in some cases we want to remove the brand. And also we can also reduce or change some of the other influences from the driving. So maybe if we're comparing our sound to a competitor sound and the competitor performance is a little bit different, we can neutralize that in the NVH simulator so that we're really concentrating on the sound and not the other influences from the car. Oops. Yeah, and then we have for us, the main thing is like I said earlier, we have a production ASD system where we tune the car. And the big thing here is then we can directly, when we've finished in the NVH simulator, we can directly transfer the ECU into the vehicle, and we almost have a finished product. So here I'll just show you a little bit about the hardware that we use in our hill system. So we start with a ECU. So this is, let's say, the core of the active sound system. And then in this example, we have an actuator that's mounted on the bulkhead of the car and radiates the sound into the car through the windscreen. And of course, the ECU drives the actuator. The ECU, of course, then needs the vehicle data. And in the case of the simulator, we have a driving simulator model. The driving simulator model is using the bass sound of the car without any active sound. And of course, then the driver, the inputs to the model is through the steering wheel and the pedals. This is outputted via CAN bus. The simulator obviously has its own CAN bus system, so we run our system through a CAN router, which allows us to change the CAN bus signals to native Hyundai CAN bus, but also allows us to do some maths channels or some manipulation of the channels as well. So maybe we want to add a torque map or some other, let's say, quasi channels that are not in the actual driving simulator files. And then we feed this CAN bus then directly to the ECU, so the ECU effectively thinks it's inside the vehicle. Then, as part of the NVH simulator, we have the audio mixer, and we take then the sound directly from the NVH simulator. And then also what we do is we take the sound from the ECU, or the output from the ECU, if it comes, and we remove the actuator. So we've got a little black box in the middle because, of course, the ECU expects some sort of load from the actuator. So we have a little black box which turns the signal into an input. And we have then both the bass car sound into the audio mixer and then also the active sound part. And then, of course, the audio mixer then gives the output of the combined sound to the Jura. So then one last thing is then the sound design software. So like I said, we use the actual sound design software that's part of the, let's say, the vehicle development. So it's not part of the simulator one or anything else. It's the one that we're really using in the vehicle. And we can then also connect that directly to the ECU, maybe, so that we can then do real-time tuning of the ECU. There are some other considerations that we do as well, and this is really to aid then the end application into the vehicle. And this is that we measure the FRF function between the actuator in the car to the driver's ear. And the reason that we do this is that we want to add in the signal between the ECU and the audio mixer, we want to add a frequency response function, so that when we take that ECU and take it out of the simulator and put it into the vehicle, that we've got the same sort of response at the driver's ear as we would have had in the simulator. And this then reduces the amount of development time then when we go to the end vehicle. Okay, so just a bit about the development process. So we start with the NVH simulator, and like I mentioned already before, we have the base model in there, and we start creating then the concept sounds. Sorry. And then we get to the pre-selection. So maybe we make 10 concept sounds, and we can use then the simulator maybe internally with some of our colleagues to select some of the more interesting sounds. And then what we can do is from them sounds, when they're selected, we go to the fine tuning and do some concept tuning, and then we can move on to the jury evaluation. So once we've got maybe 10 sounds, let's say, we ask the jurors to play all them 10 sounds and then tell us which one of them 10 sounds is their preferred sound. And at the end of this, then we can have a final sound selection. So maybe it's, in the last case, we pick then the 3 sounds for normal, sport, and N mode. And then we can go back to the simulator again and just do a final sign-off with the management, just so that everybody's happy with the sound as we expect it to be in the vehicle. Like I said then, yeah, thanks. We can then move this to into the actual adaptation into the vehicle. So we basically, in the case that I've just showed, we can unplug the ECU from the simulator, take it down to the vehicle, plug it in the vehicle, and yeah, I don't want to give figures, but we can be quite close to actually what we want when we play the sound. It's actually sounds quite close to really what it was in the simulator. Of course, the environment inside the car and the acoustics, we have to do some fine tuning just to make sure. And we do this and make sure that we've got then the same end sound as we had in the simulator itself. And then the final step is that we can do then a real vehicle sign-off drive with the management. So yeah, so that's the development process. So now just a little bit about the future integration into virtual development. So yeah, virtual development. Many things that we want to do in virtual development. I think at the moment we're still at the stage of very much having hybrid models where we've got a test-based model and that we start replacing then a lot of the test information with CAE. So maybe we're taking parts or components that we then calculated in CAE or optimized in CAE, and then we feed this back into the NVH simulator and replace the parts, and then we can replay that sound and vibration in the simulator. So yeah, like I said, to do this, then generally we have then the base model, so a recorded vehicle, recorded sound. And of course, then the CAE model, we need to make sure that this is also well correlated with the real vehicle. And then we, for example, take here an engine mount where we want to optimize the engine mount. We do this in CAE. We can then calculate the response functions in CAE, and then we can add this to the simulator model. You can see it then obviously as a graph, but for us then the main thing is that we want to then be able to listen to this or hear or feel this in the vehicle, and then we can go back again and feed this back into the simulator and evaluate the response. So really just a very quick overview of the future integration. So thank you for your attention.